Yoski. So what we have here today is the USB dummy load, a project so small and so simple that I haven't actually put it in any of the spreadsheets, but nevertheless, as mentioned in the diorama video, let me just start by demonstrating you what the frustration and the problem is. And this is just a mechanical adapter for the sockets. Let's use this power bank with the 1 amp output, yeah, and yeah, so it's just USB to USB-C to USB again, because you know, dongles. Now watch the LED, I push the button, start the timer, and yeah, so you would assume that this sort of a thing should just be going on pretty much as long as the power bank has charge in it, but alas, it will not. Which you will see that. Let us run that in the background. And yeah, the exact timing doesn't matter, it's just to show you that the time is actually passing and I'm not doing any editing. So let's get to the project itself. So to start, these adapters, they are really nifty. It's a super simple device. You have 3 inputs, well, 3 sockets and 1 plug. It's a standard USB plug, USB-A, so standard USB socket. Then we have USB-C socket and micro USB socket, which basically means that with this you can connect anything to anything. Which is why, as you can see in this corner, I've bought a whole bunch of them and they are reasonably cheap. It's probably like 50 cents a piece. And another additional feature that they have, which is extremely useful for our particular use here, is that they have 2 like pin headers. Well, these are not as places where you can solder headers of your choice, and you know, everything is connected with everything. So you know, the VCC here is like VCC for the whole thing, and the same goes for the other pins, which means that this is, and as you can see, this is no longer working. Now we can reset that, I think, turn it off, turn it on again, and now you see it doesn't even leave again. You probably have to unplug this. Let's try the other power bank. Yeah, whatever. Yeah, okay. Oh, the timer is so wonky, but anyways. Yeah, let it run. You see, different power bank, same situation, everything is the same, just a different power bank. Let's see how long that runs in the background, and let's get back to the thing. So as you can see, my practical choices here were to have sticking pins on one side and a pin accepting part, so like a male and female parts of it. And this is actually extremely good, because when you think about the sockets here, you can just stick a resistor like directly, like take it off wherever you have it and just stick it directly inside the holes and it's connected. And on this side, like having the pins exposed, it's very easy to put like a probe, or maybe even like a PC, standard PC jumper, you know, like in the olden times where you had spinning rust mechanical drives. Because yeah, the thing about, at least in theory about it, is that, you know, this is just a basic USB, so this is not USB-C or like anything, just has 4 pins. So you have the VCC and GND, which is basically your plus and minus, and then in the middle is like D minus, D plus, which are the data pins, which are supposed to send data and not power. But what you will read from the internet after, you know, even cursory googling, is that in theory some power banks, power chargers, adapters use the resistance between the data pins to tell how much power they can supply. Because you see, in theory, the original USB standard was at most, I believe, quarter of an amp, so 250 milliamps at 5 volts, giving you like an amp or whatever, like a watt of or whatever of power. Then that was increased to half an amp, so 500 milliamps. And now basically the standard is that anything will do at least 1 amp, so at least 5 watts, you know, 5 times 1, 5 watts. And if you want anything more, that's non-standard, yada yada yada. The point is that, as you can see already, this is 2 minutes. The previous one was probably, I don't know, 45 seconds, and it's still running. You don't even need the dummy load. This power bank actually works, this one doesn't. And that's the whole problem with this. Each and every power bank will have a different threshold of when it decides that the stuff you plugged in is powered, is already charged, and then it will basically stop working. Which is why this thing comes in handy, because it's very easy to experiment and you don't need to calculate anything. You don't need to, can you just stick in your resistors and see like how low have you go, how low do you have to go, apologies, tongue tangulations, to actually get the thing working reliably. Because as you can see, this is working reliably with just the adapter, no need for additional load. Now, speaking about additional load, so this is what I've done. This is these are 200 ohm resistors in parallel. So we have 50 ohms, like in those in this package. So this at 5 volts gives us what, 100 milliamps. So 100 milliamps base current. And I've tested already this with this thing, and it still shuts off because this little LED, it's taking like 8 milliamps, 7, like less than 8 milliamps basically. So that's still too low. If you want to just to be silly and power just this LED with this power bank, you would need probably 2 of those to like draw twice the amount of current. But yeah, I mean, the whole point here is that the flexibility of this setup. Again, I have like a PC jumpers that I can put on the D pins, basically short them, so zero resistance. I've been told from the internet that this is supposed to give more power. You know, like again, my personal experience that each and every power bank will have different characteristics, and whatever's there in the standards is only there in the standards. So you know, your mileage might vary, but with this you can quickly experiment. So it's super easy to make. This is a beginner's project. It's just soldering stuff in place. And the one last but not least thing, as you have probably realized, you might have never seen such resistors before. You might be more familiar with those resistors, those small ones. Because you see, these ones are, I believe, quarter watt. So again, quarter watt, these ones are 2 watts. And yeah, for this sort of application, 2 watts in theory is like 50%, 100% error margin, but you want them beefier. Again, I was using this with the, not with the diorama project, but with like a, I think 5-meter USB LED blinking light strip over a couple of months, and these get hot. I mean, not scalding or like they won't burn you, but they're gonna get pretty hot. So yeah, the Kapton tape is overkill, but I like it. And yeah, as you can see, easily pluggable and unpluggable. So in general, I think the USB dummy load will be something that will stay and will be in actual practical use. And I've been talking to you for 5 minutes, well, 8 minutes, apologies, and I haven't even plugged the damn thing in. Well, I guess I'm not really cut out to make short videos. But then again, I do not treat my viewers as squirrels. You know, instant gratification, well, you have TikTok for that, or whatever. But yeah, let's try it with the other one. It does to show that nothing here gets on fire. Yay, we're working. I mean, I don't think this will actually last that long. What else there? Well, the calculator is here only because I was checking the current draw, like, you know, like 8 milliamps, because this is like 660 ohm resistor, and you should trust the math. Let's set this for fixed. Wait, mode 7. 3 points, okay. So we have 5 volts divided by 660 ohms equals 0.008. That is 8 milliamps, and this is already rounded up. So yeah, extremely low power. I mean, that's the reason why you have blue LEDs in everything nowadays. They draw so little current that it's just it's actually mind-boggling. It's like 3 orders of magnitude less than a red LED. So my assumption is that just to make everything last longer on the stupid batteries, everything is blue now. So yeah, at least that, they are efficient. And what do we have here? Is it working now? So a minute and 10 seconds. It wasn't working before, which again shows you how fragile the balance here is. And I would say that if you don't mind using more of the power from the power bank, don't go with 50 ohms, go with like 25, 30, like even more current draw. Probably something like 200 milliamps would be like a good baseline. Because again, if you have something that needs a lot of power, then you're just gonna plug it in, it's gonna work. This is all about this like low power stuff where such a power bank should, power constantly for days, if not weeks on end. So yeah, apologies for a bit of a, for exactly for that. I do not script my videos, I refuse to do that. So sometimes they are more structured and sometimes they are not. In any case, you can make your own. And if you have any ideas or things about using power banks as batteries, please put them in the comments. Send me links, send me stuff. I really find it very frustrating that it's so painful to use power banks as batteries, and as you can see, we have power banks for days. In any case, thanks for watching. I'll see you in the next one. Bye.